Hey everyone, and welcome. Today, we are diving deep into a personal obsession of mine, and I think a universal quest for so many of us, brewing that perfect cup of coffee. And, it feels like an art, but it's also a deeply, deeply fascinating science.
So, let's just start with this one question. What if science could actually brew your perfect cup? I'm talking about using chemistry, physics, and even AI to engineer your ideal coffee, right down to the last molecule. Well, today we're going to explore exactly how that's possible. All right, so before we even think about brewing, we have to go back to the beginning. We've got to understand our raw material. The whole journey, the entire process starts right inside the coffee bean itself, with its very own chemical signature. So let's look at the two big players in the coffee world, Arabica and Robusta. It really is a tale of two different beans. Arabica beans, they're packed with more sucrose. Now, that's sugar, which breaks down when you roast it into all those sweet caramel and fruity notes we love. Robusta, on the other hand, it's a different beast. It's got nearly double the caffeine and way more chlorogenic acid, which gives it that really powerful, bitter, and kind of punchy kick. And if we break it down even further, you've got these four main building blocks of flavor in pretty much any coffee. You've got alkaloids, like caffeine, which bring the bitterness. Then you have acids, which give coffee that bright, sour note. Of course, you've got sucrose for sweetness. And then there are these amazing compounds called furans, which pop up during roasting and give you all those nutty, malty aromas. Every single bean is basically a complex little cocktail of these four groups. Okay, so with all this crazy complex chemistry going on, how in the world does anyone maintain a standard for what makes good coffee? Well, that's where the Specialty Coffee Association, or the SCA, comes into the picture. They've created this incredibly rigorous system to evaluate coffee beans from all over the planet. And this, right here, is their gold standard. For a coffee to earn the title specialty grade, a 350-gram sample of the green unroasted beans can have absolutely zero of what they call primary defects. We're talking things like sour beans or mold. And it can have no more than 5 secondary defects, like a chipped or broken bean. Seriously, it's an incredibly high bar to clear. Okay, so we've got our high-quality beans. They're just brimming with all this chemical potential. Now it's time to actually get those compounds out of the bean and into our cup. And that, my friends, is where the physics of brewing takes over. The size of your coffee grind is absolutely critical, and it's all governed by a scientific principle called the Darcy-Ferkheimer law. Basically, it describes how water moves through something porous, like, well, a bed of coffee grounds. If your grind is too fine, the water gets trapped, and you over-extract all those bitter compounds. Yuck. But if it's too coarse, the water just rushes right through, leaving you with a weak, sour cup. So here's the key takeaway. If your coffee tastes bitter, try a coarser grind. If it's sour, go a little finer. It has to be just right. Now check this out, because it might surprise you. A really fascinating study back in 2020 found something that kind of goes against a lot of traditional barista wisdom. They discovered that using less coffee, just 15 grams instead of the typical 20, and a coarser grind actually led to a tastier and, more importantly, a much more consistent and reproducible shot of espresso every single time. Of course, how you brew makes a world of difference. Think about it. A pour-over just relies on gravity, which usually gives you a lighter, more delicate, fruitier cup. Espresso, on the other hand, uses immense pressure to force water through the grounds, extracting those deep, creamy, intense flavors. And then there's cold brew, which uses time, a lot of time, to slowly and gently pull out those sweeter, less acidic compounds. Each method is a totally different physical path to a totally different kind of perfection. And we can't talk physics without talking temperature. The sweet spot, according to the National Coffee Association, is right between 90 and 96 degrees Celsius. If you go any hotter, you start pulling out way too many of those bitter-tasting alkaloids. But if you go any cooler, you might not get a full, rich extraction. It's a very delicate balancing act. So, we've covered the chemistry of the bean, and we've covered the physics of the brew. But what if we could take all this amazing science and just launch it into the future? What if we could build an AI barista? Just think about this for a second. We know that a specific recipe, beans, grind size, temperature, produces a certain taste. But what if you could flip that around? What if you could start with the exact taste you want and have something figure out the perfect recipe for you? In the world of math and science, this is what's known as the inverse problem. Instead of predicting an outcome from a known set of inputs, you're trying to figure out the original inputs that created a known outcome. And trust me, it is a much, much harder puzzle to solve. This is the perfect analogy. It's like you hop in your car, you tell your GPS exactly where you want to go, your perfect taste, and it just instantly calculates the best route to get you there. That's exactly what a team of researchers set out to do with coffee.
So step one, they had to solve the forward problem. They trained a neural network on thousands of simulated coffee brews. Now, I know these charts are in Italian, but just follow me here. The chart on the left shows how well the AI predicted the amount of caffeine, that's caffeina, and the one on the right is for chlorogenic acids, which give you bitterness. As you can see by how tightly those dots hug the red line, the AI got ridiculously good at this, learning to predict the final chemical concentrations with over 99% accuracy. So once it mastered that, they taught it to work in reverse. Again, we've got some Italian labels. The chart on the left shows the AI predicting the ideal brewing temperature, that's temperatura, and the one on the right predicts the perfect blend of two different beans. This means you can now give the AI a target chemical profile, say low acid, high sweetness, and it can literally reconstruct the perfect brewing recipe to create it. It'll tell you the exact temperature to use and the precise blend of beans you need.
Okay, this is where it gets mind-blowingly cool. This 3D chart shows how the AI actually sees the data. Each one of those little dots is a different cup of coffee plotted out based on its chemical profile. And what the AI found is that different grind sizes, coarse, optimal, and fine, create such distinct chemical signatures that they form these completely separate clusters in 3D space. To the AI, flavor literally has a shape. It can see the difference between a good grind and a bad one as clearly as we can see the difference between red and blue. It's incredible.
So, after all of this high-tech science, from chemistry all the way to artificial intelligence, it's actually pretty easy to forget the single most important variable in this entire equation, you. And really, this is what it all comes down to, right? Science can give us all the tools, the rules, and the understanding to control every single variable. But at the end of the day, taste is personal. The perfect cup of coffee isn't the one an AI designs for you, it's the one that just tastes perfect to you. So now you're armed with the science. You know about the chemistry of the bean, the physics of the brew, and even the future of AI baristas. The only question left is, what kind of perfect are you going to create? Thanks so much for joining me.